All right, welcome back. We are COMP123. That's Programming 2 in the summer 2020 semester, and it's week 7, part 1 of our broadcast. We're talking about exception handling today, and we're going to be talking about file I/O on Wednesday. So lots of work to be done. These 2 weeks are going to be, it's like 2 weeks compressed into one, because by week 8, starting next week, I'm going to be talking about user interfaces. So how do we make user interfaces with C# with Windows Forms? Okay, so kind of getting you guys going with that. And also this week I'm going to be giving you another assignment that's coming up. So I've prepared you by talking about inheritance and polymorphism over the last few weeks. All right, so kind of from week 4. Week 5 and week 6, right? So we've talked about inheritance polymorphism a lot, right? So enough that you guys can should be able to understand most of the things that you need. And I've taken 3 weeks instead of 2 weeks. Typically I only do 2 weeks of inheritance and polymorphism, but I've taken an extra week with you guys just to make sure that you guys got it straight. I think if you don't have the inheritance and polymorphism stuff, then the rest of the things that you learn here in this course are, in my opinion, secondary. So a couple things. So again, just from a schedule perspective, just keep us on track. So notice that we've covered this in this material right here, right? So, and you should have already finished assignment 2, if I'm not wrong. And then we're into this material here. We jumped all the way to week 8, right? Where we did inheritance, and week 9 polymorphism. We covered these 2 weeks, right? In terms of materials up till week 9. Okay, so I think that's really, really important. And now we're back to week 5's material. So again, we're jumping around. Notice that the chapters are also in a weird kind of format. I've kind of followed along with the chapters the way they originally were, and I like that way more, and that's why I'm doing it this way. You're still getting the same content, you're just getting it in a slightly different order. Okay, so we're back to exception handling, and instead of taking a week to do exception handling and a week to do file I/O and serialization, we're going to do this together in 1 week, right? Which is going to save us the week that we lost from doing 3 weeks of inheritance and polymorphism, and I think it's a better split, in my opinion. All right. So then, this week, I'm going to give you guys assignment 3, like it says here. So week 7. You're still going to get assignment 3 this week, and we're going to make it due in a couple weeks, so that way you have a chance to get it done. So it's going to be due around week 9 when you're going to get assignment 4. Okay. That's when it's going to be due. I'm going to give it to you on Wednesday. So I'm going to have the updated assignment. I already have the assignment 3. I'm just going to update it for our new standards. Right, that's what I'm going to be doing, and I'll post it for you guys very shortly. But it's going to be more or less around inheritance and polymorphism. That's what the assignment's going to be around. Okay, should be fun and straightforward for you guys to do. Okay, so that's what's coming up this week. So again, we're doing exception handling starting now, and then we'll hit file I/O and serialization. So I put the PowerPoints up online on eCentennial. That's also something to note. So if you look at eCentennial, there's exception handling. You can read ahead. File I/O, you can read ahead for these 2 things. These are the things I'll be covering. I won't be going through every slide again, because I don't think that's a great way of teaching. So that's where the information is for what you need. Okay, let's get to it. So what is exception handling? What are we going to be covering? Exceptions are basically thrown when something goes wrong with your code. And there's many ways to throw an exception. Sometimes an exception is thrown, and what ends up happening is it breaks your code, right? So it takes down your application. And the one thing you don't want with your application is for it to be taken down from something that you do in your code, right? So if you're coding along, and let's say you divide by 0 or something like that, which is a very common thing that happens, and then all of a sudden your code breaks, your app shuts down, or you're trying to load a file. Files, whenever we do file manipulation, that's why exception handling and I/O go together hand in hand. What ends up happening is you get an exception because you're trying to open something or close something that doesn't exist, and then it's going to shut down your application. Any kind of shutting down your application in the real world is a very bad thing if your application crashes, right? We want to avoid that all the time. So what we want to do is we want to create almost like a structure for how to catch these exceptions. We want to handle the exceptions. If we have an unhandled exception, a lot of times it'll just shut down our code. So we're going to do some new examples this week. We're going to go away from the whole game object stuff that we were doing before, because I think those are nice examples, but for polymorphism and for inheritance, not bad. But for what we're doing as we go forward, we don't need to use those right now. So I'm going to pull up Visual Studio. So please pull up Visual Studio with me as we code along, as normal. And guys, I'll also be looking at your questions and all that kind of stuff. So let's make sure. I'm going to make a new project in Visual Studio 2019, just like before. And again, we have two options, at least I do. Console app with .NET Core and console app with .NET Framework. I want to use this one. Okay, and I'm going to click next. And one day when my computer is going to do its job, then we'll get to the next screen. Yeah, they were. So the project name that we're going to do is we're going to say COMP123 in the summer 2020 semester, and it's lesson 7, part 1. And this is pretty good. We might do a part 2. I'll see how it goes. Okay. So we're starting from scratch today, and for a couple reasons. And one day when this thing decides it's going to do what it's supposed to do instead of giving me a white screen, there we go. Then we'll be good. Okay, cool. So we've got our little program. It's, part 1 and so on. No, I don't want to upgrade right now. Thank you very much for that detail. And I want to start with the program. Okay, so start something very simple. So again, remember we want to do a console read line, right? So just like we did before, console write line is as a shortcut, no problem. But a console read line, there isn't really something that does that for us as a shortcut, which is kind of sucky. I don't like that, but that's okay. It's not a big deal. So again, console.readline is okay, right? That's going to set us up nicely, and this is going to kind of like wait for any key is what this is really doing to kind of start off. And what I want to do is I want to make a float as an example, and my float is going to be called the numerator, right? And my numerator is going to have a value. I'm just going to assign it a value by default. Let's say we'll give it a value of 5. And then we'll use a denominator. And we'll give the denominator a value of 0. Okay, I'll also give my numerator a value of 5.0. Right? Someone was on the mic. Ming Sing Kong, I had to mute you. Please stay muted at all times. All right, thank you. All right, so so my numerator and denominator, I've got these two things, and then what I want to do is I want to have a result, and I want my result to be equal from, I want to take the numerator and I want to divide it by the denominator, right? Okay, yay. And what I want to do now is I want to output that result. So I want to say console.writeline. You're going to see the problem already, right, as we do this. I want to say, the result is, right, and this is knowing that there's going to be a problem, right? And we'll do the old way of doing things where we have the results, something that we concatenate on, as opposed to using C#'s interpolation. Okay, so again, very simple way of doing things. And if I was to run this thing, of course, then what we're going to get is what we would expect, which is an issue, right? And we get the result is infinity, right? And this is wrong, right? This is not a good result, because 5 divided by 0, anything divided by 0 is good. Somehow we've been able to handle the result, which is not what we was intended, or we're getting an error actually, because that's not the result that we wanted. Okay, so numerator divided by denominator, anything divided by 0, we're going to have a bad problem. But the reason why this is weird is because, and I'm just going to put it out there as well, these are floats, right? So single precision as an example, right? So if I was going to print out the denominator by itself, so let's just comment this out for a second, or just basic math, right? So if I was going to print out the denominator by itself and not the result, so the denominator, that's the bottom of the fraction, right? We're just talking basic fractions. Then you're going to see that it's good. We're going to get 0, not 0.0. And the reason why we get 0 is because we format, when we concatenate two things together, we format stuff. So denominator is definitely 0. It's showing 0. When we did the division, some weird things happen. A lot of times when we get issues is when we get user input. So there's two real reasons why we always want to use some kind of exception handling. One part is we want to make sure that we catch the problem and we handle it. If somehow we have an unhandled error, especially something like, there's a couple ways we can do this. For example, if I have an array that goes out of bounds, that's another way. Okay, so let's say I have an array, and my array is going to go, beyond its limit. I'm trying to index something that's longer than what it's supposed to be. So that's one thing. The other thing is if I get some kind of input from a user and the user's input is incorrect. Like I'm listening for a number and I'm trying to convert it, and I'm not going to be able to convert it. Okay, so let's do it that way. So now we know what these are, numerator and denominator, right? But let's get input from the user to do that. So again, what I'm going to do here is they're going to be floats, and I'm going to do a couple things here. So console dot. So I'm going to do a read, not a read line, and we're going to read from the console. Now notice what it says here. When we read the next character from the standard input system. If I read line, so read line, I read whatever the line is going to be, right? So console.readline, if you notice, says no parameters, right, is what it's going to take. That's the option, right? And that's what it tells us. It says reads the next line of characters from the standard input stream. So that's our flavor text, if you will, or what we're going to get. And it's going to return something. It returns a string. So for example, I want to read line something, and remember, anytime we get any input from the console, it's a string. And what I want is I want to convert this string, so we'll call this input string, float input string, right? Is this, right? So we're going to get a console read line. And I want to convert this. I want to convert this string into something that I can use. And this will be let's call this, instead of an input string, we'll call this the numerator string. Okay, so here's our numerator string. I want to convert it to float in a second. And I want to give some text to the user to enter stuff in. So I'm going to do a console write line. Instead of a console write line, we'll do a console write. Right? So again, a console write is different than a write line in that I write out a string, but I don't include a \n character or a new line character, right? So I want to write a string that says something like enter the numerator. Okay, so there's enter the numerator. We'll give a chance to read something from the console, and then we'll do the same thing with the denominator. Okay, so again, instead of numerator string, we'll have denominator string here. Okay, console writeline. This will be the denominator. And before we assign it anything, we'll test our program. So we'll just run it and see how that looks. So we'll say numerator is 5, denominator is 0. Looks like it's okay, right? So it takes in some input now. The reason why we want to use write instead of writeline doesn't add an extra character. That's what it does. So it looks like it's okay. Let's also add a console writeline here just as a separator. That's what we want from these two things, right? And what I want to do now is I want to take the numerator string and the denominator string and convert them into floats. So we can use numerator and denominator. So a couple ways to do that would be to convert, right? So I want to say float numerator is equal to, and again, I want to use convert dot, and I want to make it so to single. I want to convert to single something that I want to convert. And notice that what I can do is it says my object value, it says converts the value of specified object to a single precision floating point number. Okay, I could do this, convert to single. If I had, now it takes different things, a double, a float, float to float, integer to float, long to float. But how would I make it so that it converts to a string? Well, what I could do is use this method, which is like something like, I want to convert this to float, right? And I want to convert my numerator string to float, right? Numerator string to float, right? And if I did this, let's try to make my numerator string into float. It says no, represents a single precision float, cannot convert type string to float, cannot cast expression of type string to type float. So what is the way to do it? How do I convert a string to float, guys? Who remembers how to do that? I want to convert a string to a float. I want to convert a string to a number. What do I do then? Convert to float. Okay, let's try that. So convert dot to float. There's no to float. There's to single, right? So if I go to single, which is this one, and I pass in a string, so I go like a numerator. Okay, exactly what I did. I'll take the string and I'll convert it to float, and at the end we'll have a float at the end. Okay, cool. Let's do the same thing for our denominator. So I'll say denominator, right, is equal to convert dot to single precision, denominator string, right? We're just doing this over a couple lines here. And then what I want to do is result is equal to, like we did before, numerator over denominator. Okay, so kind of very simple example, right? So maybe if I can actually type in result, like float result, how about that? And then print it out, right? We'll do console writeline as a spacer. That's kind of a waste, but who cares? And we'll also do a console writeline that says the result is, and we'll add that in as we'll append that this time. We'll concatenate this as a result. Okay. So this is going to be okay if we type in the right values, right? Because remember, user is inputting this stuff. You don't know what's coming inbound, right? When we did this before, 5 divided by 0, we knew we were going to get a 0, right? But there's lots of stuff that the user can do here to mess us up. A ton of things. Let's try this out. Let me see if I can break our code here together, right? So first, let's run it. So numerator, I'm going to type in 5. I'm going to type in 2. And then you're going to get the result, 2.5. Nice. Okay, and let's try it again. I'm going to type the number 3.5, and I'm also going to take 1.5, and we're going to get a value. Okay, and then we're going to get. So the user in this case did what they were supposed to do. Okay, and let's keep going. We're going to take a value 5, and we're going to divide it by 0.0, and then enter. The result is infinity. Okay, somehow it was okay, it didn't break. Great. All right, now let's take a value, and the denominator is, and the result is this, an exception. And it broke our code. This is what I'm talking about, breaking our code. See, we're here and it's broken. It doesn't work anymore. And imagine you bought an application and it says unhandled exception, and we're going to get this error. And it won't show it here. It'll just actually show this little white window that says unhandled exception error number, blah, blah. And you're going to be like, what? What happened? I bought this application and my application broke? Not good, guys. Right? So we want to handle this exception. And part of exception handling is we want to wrap our input. We want to wrap our input or our when we do our division here, we want to wrap this up in some kind of actually even the conversion. The error happened right here. We're trying to convert from an alphanumeric key sequence into a floating point single precision number, a data type, right? We're converting data types here. So it can happen here, and it can also happen here, some kind of weird exception, okay? So the way we would do this, let's do the first one, is we use something called a try catch. So I'm going to give some space here, and you just type in the word try, and then if you press tab once, right? So press tab once, you're going to get this, exception E, and then blah, blah. The form of try catch can literally be just this. So try catch, if I did a try catch, no brackets, like this, and notice it says empty general catch clause suppresses any errors. So this is bad. If you did this, what it's going to do is it's going to basically be, if I catch an error, nothing will happen. I can just suppress the error like it says, right? And what you want to do is you want to take this code block right here and wrap it around the stuff that we have. So I can take this stuff right here and put it inside the try block. So what the try block will do is it'll tell the compiler, say, okay, try and run this thing, okay? If this thing fails, right, to run, if it throws an exception, then do this part, okay? Then do this part. And what we can do here is we can say something like console writeline, you know, your input generated an error, right? You can give a feedback to the user again, saying something happened, right? And let's add our extra console writeline in here just to give us an extra space, just to be quick, right? So let's try this again. So if I did this, wrapped everything in a try catch, it looks like this. Just one more time for those people who are watching remote. I want to enter a numerator. Again, I do a alpha and a denominator of 5. Press enter. It says your input generated an error. But guess what? My code didn't break. Okay? It didn't break. So that's what it did. So try catch. Okay? And a try catch can also give us more information. All right? So generically, if I put exception, the exception is the class, and the name, I can make a variable of this type. So let's say, for example, I don't know, exception. We'll call it exception. So the variable is called exception. This is basically saying this. When we generate an exception, the exception variable is going to be, we can use, it's being caught here, right? And I want you to always think about when we try catch. When I try something, it's almost like I'm throwing the ball, you know, and if I'm playing some kind of ball sport, and when I catch something, I catch the ball. All right, if there's an error, you know, kind of thing. That's when I kind of look at it. That's why it's called a try catch. Catching, this catch section, the catch block, is where we catch the exception. Try is when we're trying to run our code, the try block. Okay, and the exception itself right here is something we can use. So I can say something like your input generated an error, and then I can actually generate the error. So console writeline, and then I can say exception dot, and then notice that it has a bunch of things, but a couple of them is message. This one is the important one, message. So the exception message is a special message or a string that's being generated by the exception that's being thrown. So example, if I was trying to run this again, I did this exact same thing, A, and press enter, and then ran a denominator of 5, it's going to say your input generated an error, input string was not in a correct format. And that next part, input string was not in correct format, right? came from the general exception being caught, and what's happened is it's just going to throw a generic error. This is a generic error that's happening, that's coming from our system detecting which exception was thrown. Okay, so that's the way it works. Okay. We could also have other exceptions. Remember, users can do funny things, right? Users, if they, like we said before, if everything would be awesome, right? This is the way the common thing that's being, it's always said, is everything would be awesome if we didn't have any users, right? Because then, we wouldn't have any errors. But without users, we wouldn't actually have any business. So that's bad. So let's say I made my numerator very large, right? I'm just going to make it a very large, stupidly long number, like this, right? And I made my denominator also very large. I'm just randomly typing some digits, really long number, and really long, okay? And I'm actually entering a float. Now press enter, okay? It says your input generated an error. Value is either too large or too small for a single. Okay? That's interesting. Too large or too small, right? Because we're not really giving instructions here to the user, right? We're just telling them, hey, give me a numerator and a denominator. We're going to, divide those two things, right? And it's really large, right? The same thing that can happen is if we make it really, really small. So I say something like some negative number that is really, really big. So a really big, how about this? A big alphanumeric number. No. A big kind of negative number, right? Divided by, 0. The result is a negative infinity, like it says. But it's big enough. The numerator wasn't big enough for it to generate a problem. Let's try again. And again, this is how you would try and break code. So I want to make it something really big. A very, very long sequence of numbers. It's much more precise maybe than I could. If I divide by 0, we're still pretty good, right? You can see that one thing or the other thing, for the most part, this is okay, right? But the big errors come from things like alphanumeric input, files that don't exist, and so on. But we want to give contextual feedback to the user for what happens. So this here, exception, is a generic exception. It's a catch-all, this kind of thing, right? If I want to catch every exception, I use this, okay? That's what this is. But I can catch specific expressions as well, exceptions, right? For example, and let's go back to our PowerPoint for a second, because in our PowerPoint, it really shows a bunch of different things that you can have. So again, there's different exception classes that we can try. And I'm just going to go through here. It should have a bunch of different ones. So here's different ones that you can use. Okay, this is kind of a reference card for you guys to use. I know it's kind of small for you guys to use it, so I'm going to kind of zoom in here so you can see different things that might cause exceptions. Oops. So an argument exception. So an argument that you pass to a method is not valid. Arithmetic exception, right? So casting or conversion problems, right? Array type mismatch exceptions, very common. Drawing and printing exceptions, a format exception. So thrown when the format of an argument does not meet the parameter specifications of the invoked method. Okay, interesting. I/O exceptions, we talked about this, right? Null reference exceptions, when we have an object that has no reference at all. And we're going to try a bunch of these. Out of memory exception, right? We can generate these nicely, right? And we'll talk about how to do some of these things. But all of these different kinds of exceptions are of the kind that we can throw. Okay? And notice it says it has the word exception in them, right? So arithmetic expression, argument expression, format expression. Okay? Let me just back out of here again. So that's kind of the way exceptions are thrown. They're thrown based on errors that the user makes. It's not a syntax error. it's an input error typically, or some kind of value there, or something you're trying to do. Example, divide by 0, right? So again, C#, the latest version of C# is smart enough to avoid division by 0. But what if we want to have a special type of exception? So instead of here, we can say, well, I want a format exception to go here. Notice how it came up, format exception. I want to call this exception, and I want to kind of pull up the message that I want. You can still do this, right? And if you try to do this for a second, here's my format exception. Then in this case, as an example, if I did something like an alpha and a beta, and I did this, then the input string was not in the correct format, it worked, right? So, but what about if it was the very long number thing? These are more specific type exceptions. I'm expecting a format problem where a user enters the wrong message. Now I know that the message is incorrect input, right? It's a format exception. A format exception comes from things like we said before, right? Some kind of issue, right, with an input. Let me just put that back for a second. So you can say, instead of your input generated error, you can say you must enter numeric or numbers. You know, you must enter numbers, right? So as opposed to you know, some kind of text, right? Alphanumeric. It doesn't stop you from entering that, right? There's no way of stopping you right now. So that's one. But what about if I wanted to enter long numbers like we did before? Will it be caught or the way this is right now or not? And if you notice, if I went back in there and typed in a very, very long number again, really, really long, and I'm just randomly pressing some digits here, and same thing on the back side. Let's say something really, really long on the other side. There's a really long thing. I'm going to get a number because one of them is okay. Let's try that again. I couldn't duplicate that. Something that's really, really long on both sides. So from a precision perspective, and I'm not sure if this is long enough. Yeah, I don't think the numerator is long enough. Let's try that one more time. One more time. I want to show you what I'm talking about here, because you would notice here. Let's do this and something that's really long, much, much longer than normal. Oh, wait, that was an error. That's gonna be a format error, and so is that. Gotta watch my numeric keypad here. Okay, really long digits. It's like I'm playing the piano, guys. And it's really long, crazy digit that I'm getting, and I press enter. I'm still going to get this problem. And the reason for it is because, that's what I was hoping to get, a system overflow exception, the value was either too large or too small. Overflow exception is what we're looking for, right? So notice that we caught the other one, that you must enter numbers, but we didn't catch that one. So you have to have another catch block. So catch, and we want to call system, so basically an overflow exception. Overflow exception. So we call this the overflow exception, right? So we can have several exceptions, and we can respond to those as well. So again, I'm going to copy these lines here. By the way, notice that this exception does not work in this code. It's not even found. The reason why is because it's been created in this code block, and so it lives and dies in this code block. It doesn't exist here, even if it worked and it was the right kind of exception. In fact, what we should do is we should refactor this one. So we should refactor, rename this exception so it makes a format exception. Format exception actually gives us a value to do it, and that makes more sense. Format exception. This one should be an overflow exception, and your numbers were too big or too small. Okay, and so I really don't need this message. In fact, I can ignore or suppress the message, even though it's being caught here, right? I don't have to use it. I'm going to show you this, right? So if I run that again, and now I have two different exceptions, it will catch either one. So if I do this, it'll catch the string is incorrect format, input string. You must enter numbers, which is what I put in here. You must enter numbers, right? And the other one is that very long number now should also be caught. Let's see if I can replicate it one more time. Really, really long sequence of numbers. And yeah, I'm playing piano again. You get the point though. So I can catch different ones with the same way, and this time it just says your numbers are too big or too small. So I caught both types of exceptions this way, right? So when you want to specify that you want to catch these two exceptions, you can do that, right? I know that these two things can cause either one of these two errors off the top of my head, but sometimes what happens is we don't know. There might be another error, so we can do another catch block, and again, you can just type any old exception or leave it blank actually, like this, and this will catch. It's a catch-all, right? So this is kind of the catch-all block, right? So any kind, this will catch all exceptions. Catches all exceptions. All right, and this is not good. Be careful because it won't error out this way, right? We can also do like we did before, just a regular exception, right? So, and we can kind of do an error that says, something went wrong, right? Something went wrong. And then we can output the message, which is kind of what we want to do, right? So something went wrong, some other kind of exception that we didn't think about, a generic exception, and then the message is going to come up. And now we know those, so we can do multiple exceptions to catch this problem. Okay, so there's definitely one part of exception handling. Any questions around this and why we need it? Okay, so far you don't see it because the example here in my program.cs is very simple, right? Like really, really simple. But again, I want you to think about it this way: the number one place to get exceptions happening is users. Users incorrectly input or give you input to something. They touch the wrong thing, or they enter something that makes no sense. As an example, they mash keys like I'm doing or whatever. And sometimes they do it by accident, right? They don't mean to. Other times they do it on purpose because they want to break the system, right? So we need to have a way of protecting our application from breaking. Okay, and that's what exception handling helps us do. So divided by zero, we talked about this, and it talks about here in this PowerPoint a bunch of different ways and what these things mean. So the try block contains statements that can produce an error, and the catch block catches the error and reports the exception type. Here's an example of whatever the exception is. In this example, you can see that XXXX means it's some kind of exception that we're catching, and we can specify which one we want. We can have a series of exceptions in a row, like we said. And we can also use the getType method if we want to. But take a look here. So this is what I'm talking about here. A divide by zero exception, which is possible, right, when we tried this numerator-denominator thing. Now this was done with integers. And funny enough, the denominator with integers, a lot of times we'll get the error here. Here, as an example, we have an integer array, right? It's called array. And we've pre-allocated 3 values, or initialized it. Here's the initializer syntax here. And we've initialized 3 values, 22, 33, and 44. And what we want to try and do is get whatever that number is. So if I enter number 13, number is being used to access or index this particular array, and there is no 13th value. So it's going to give us 2 different kinds of exceptions. And let's try and catch that as well one more time. So going back to our code, if we convert these things, if I say instead of floats, let's make them ints, let's try and do kind of what the PowerPoint did. So numerators and denominators are ints, and we want to convert to int instead of to single. And again, notice there's int 16 and int 32. That's also a big difference. Let's make it so it's int 16s. So we'll actually generate other kinds of errors. To int 16, there we go. So int 16, and we want the result to be also int 16. Actually, we'll make it float, because the result has to be float, just like it says here. So although what they did with the result is also an integer, okay? But let's do var instead of float. We'll say we can use the keyword var a lot of times, like I said before, and we're going to see that going forward in some of our examples. Var is not like the JavaScript var, okay? Just to reiterate this, okay? Var is an implicit way of getting your type. So result, C# goes through this and goes, okay, I'm getting a numerator and a denominator, and I should get an integer back. And so that var basically casts this result as an integer type, okay? So now we get format exceptions, we get overflow exceptions, but there could be a divide by zero exception. Let's see if we can catch that. So again, we're going to do another catch block. And usually what I like to do is I like to have a, by the way, if I put catch, and there's also catch block, right? Catch block doesn't really do anything, just to let you know. But what we want to do is we want to get a, divide by zero exception. All right, we'll use this. I know it's pretty big, but whatever. You can see that I can catch that as well. It's almost like different flags that I raise, right? So again, I'm going to copy these things, and we'll go here, and we'll say, you can say like your denominator cannot be 0, right? And then we can do this divide by 0 exception where I want to show the message that I want to show. If that actually does work, let's try that. So we'll say like 5 divided by 0, and you can see that your denominator cannot be 0 came up because we did divide by 0 in this case, right? Attempted to divide by 0. Okay, so that's that divide by 0. Format exception, you must enter numbers. So again, if I go A and then F, you're going to say you must enter numbers. Overflow exception is easy for us because we've done that already, and then a generic exception if something else went wrong. We can also say that if we wanted to duplicate the same example and I want to have an integer array, so we'll say an int array, right, which we'll call numbers, right? And we want to pre-allocate the numbers. Okay, remember how this is done? In our initializer syntax, use an equal sign and a list of numbers we want to use, right? Again, I'm not assuming anything. So initializer syntax, I don't know, like 3, 5, 7, 9, and we'll say 15, right? So a few numbers in our array, and then what we want to do is we want to index after they do they enter some numbers. We want to print out the integer based on whatever the numerator was, right? So if the numerator is something large like 25 or something else, it's going to go out of range. Let's try that. So we'll say console write line, and then we'll console write line the the array value of the numerator is numerator as index. The array value of the numerator as index is, and then we'll enter the array. So plus, and we'll say that we'll give us some more real estate here. So again, we notice that's numbers and then numerator. So we're trying to convert and then we're also going to print out that thing. This is going to cause an error sometimes, right? So if we have a low number, 0, 1, 2, 3, 4, it'll cover up to 4. But what happens when we go to 5? So if I was to go do this, and if I said, okay, numerator is 5 and the denominator is 3, then we're going to say something went wrong. Index was outside of the bounds of the array. Why? Because this catch-all caught something that we didn't think about. So this is not a bad thing to put in your try-catch flow, because it'll catch things that you can't possibly think about sometimes, right? But be careful, because again, this masks some errors as well. If you put a try-catch around an error that you want to mask, and you don't put this at all, that's like, let's hide the error. I don't want to hide the error. I want to output something, give users something to to talk about. So here, what I can do is I can put another catch, and we know that this is like index out of bounds error, which is what the exception is, index out of range exception. So index out of range exception, and give me some examples of what I can use. And just like before, I can put curly braces. Oops. And we can grab some code. Must enter numerator between 0 and 4, right? That's the error that we're going to, if this is the problem, right? Which, I mean, this doesn't really make any sense. This example is a very contrived example, because that's all you can enter numbers between 0 and 4. That's bad. I mean, that's like, what a weird input this is. But anyways, let's move on. So let's say if I said 5 and 3, you must enter a numerator between 0 and 4. So it caught the exception, and it didn't go to my catch-all. Okay, so that's one thing it didn't do. Memory out of range stuff you can do with recursion, right? Where I have a function that calls itself, right? So this is kind of pretty straightforward stuff. Okay, let's get back to that PowerPoint. So that's what this does. It talks about different kinds of errors. As an example, we're catching multiple exceptions. One thing it says here is unreachable blocks. So I can't get to a particular block. As an example, some programming logic where I can't get to it, it will tell me. But there's also, we can use something called a tryparse. Tryparse is actually very interesting. It's like a try catch, but only look, but for only one thing, right? So I want to try and parse. I want to try and convert one thing, from alphanumeric input to numeric input. I can use a tryparse, and if it's false, instead of using a try catch, I can return a value. So example, instead of doing all this, if I want to just test to see if my numerator or denominator is wrong, I can't convert it, as an example, and I want them to re-enter this, right? Then I could do something like while not numerator or whatever is false, I can make it so that correct input. Let's make a Boolean, right? We'll make a while loop. And we'll say is correct user input, and we'll set this Boolean to false. So by default, the is correct user input, right? And we can say while is not correct user input, while is not correct user input, or not complete user input, whatever you want. Then we'll keep on asking the user for input until the input is correct. So we can do a while loop here. So while, and then we'll put in is not correct user input, right? So it's false. And we can kind of take care of this part, right? So we can say, hey, give me some user input that's pretty cool. And we have to say that we want to try catch these things. So let's do this, put that over here. And what I'm going to do is By the way, one thing is that we have to be very careful about is it says that numerator and denominator, it doesn't know about these things because we're actually creating something called denominator string, right? And it says that use of unassigned local variable numerator, notice like numerator and denominator are up here and they haven't been initialized. That's what it means. Let's initialize them. So they're integers. Okay. Now we're okay on this side. So we can still have a try catch block for the division part. Okay. The division part will, kind of see if it's okay. I mean, it'll catch the division by 0 problem, right? That's definitely going to be there. And it'll also catch this problem. It'll also catch the index out of range error, right? We may not have a format exception anymore because this format exception is going to be caught up here when we try it. And what we're going to try and do is Tryparse. Okay, Tryparse. So numerator, we're going to say if, and again, I'm just going to go with the same syntax that are in the slide. So if we're going to try and use an int Tryparse, and in Tryparse, there's two things you need. You need a place to receive, the output, and we need an input string to test. So that's the part of the Tryparse. We need something to test, and then some place to put the number when you actually do convert. Okay, so the number itself, numerator, would be the conversion. Okay, that's important for us to do. Okay, and then this part is the test. We test to see if this is true. If we can parse it, then we're good. If we can't parse it, then we're bad. Okay? So we can say that if, we can use an if, not int dot tryparse, excuse me, int dot tryparse, and we try and tryparse the numerator string. Okay? And then we need an output. So we're going to say out. We're going to use the out keyword and out into the numerator. Okay. If this is wrong, if it can't parse it, right, then what we want to say is we're good or we're bad, otherwise we're good. So what we're going to do is here is instead of if we can parse it, this is the better way of doing it. If we can parse the string, then we want to change, to numerator the we want to basically say that is not correct user input. We want to change it to true, but we want to do it for both. So we want to say if int tryparse into the numerator, and so this condition, and int dot tryparse the denominator string. If I can type out to denominator, if both of these are correct, if both are able to parse, if I can parse both strings, so I can do this one, I can change numerator string to numerator and denominator string to denominator. If I can do these two things, then I can change my is not correct user input to true. Okay? So while is true, actually it should be true, and this should be false. So now it's not incorrect user input anymore. We're good, right? And then we can convert, right? So we don't need conversion. We don't need these two lines anymore because we kind of do these two lines with this big line right here. Okay. So again, what Tryparse does, there's different kinds of Tryparse. We can have a different structure that we want to do. So if I want to Tryparse something else, type in float.tryparse, that works. If I want to do a double.tryparse, that works for conversion, right? And if I want a decimal.tryparse, that also works. So all those different things work. So we can try this, But the key is this part. Okay, people don't understand what this means. What does out do? Well, out is a reference, is what this is, right? So what this is basically saying is, hey, take the numeric string, the numerator string that I want to try and parse, and put give us an output. Give us an output in the numerator. The actual value that you convert, put it here. But you need to have these two things set up ahead of time in order for us to do the output. Okay? Let's see how this works. So let's see if this works at all. And if it's not correct, right? If it's not correct input, we can also put an else statement somehow. Let's say, for example, one of these two things is no good, then you could give out that same string that we put, which is you must enter numbers, right? Because that's what the problem is, Now it's not going to catch very big or very small numbers. That is not going to happen. All right, it's not going to give us this. It's not going to take care of this problem. And let me show you how we can do that. But you must enter numbers. If it's something else other than numbers, these two things will catch it. So if I go run now, and if I type in a and something else, it'll say you must enter numbers, and then it'll take us back up to the numerator again. It'll keep iterating until I enter numbers. It won't stop me from doing stuff. And to make this look nice, right, we can do a console write line, right? So that way it gives us a bit of a space, right? So let's try this again. So again, if I was to run this, I went A and D, and you can see you must enter numbers, and then ask me for the numerator again. If I do that again, it's going to keep on doing that until I enter the numbers. So if I do numbers 5 and 0 now, right now it says your denominator cannot be 0. Why? Because now the input, once I have proper numbers, this is just making sure that they're numbers. Here, what this does is it tries to do the division, this part, right? Now the try catch comes into play, right? Because, yeah, sure, we got numbers. We tried to do the conversion. We converted, right? But now after the conversion, okay, does these numbers make any sense? Are they too big? Are they too small? Whatever, right? And I think that's kind of the way that try catch can work nicely, okay? So questions about Tryparse and try catch. Two different things, right? I think combination of these two things is great, right? Tryparse, especially when you're converting. I think converting is the best way to do this is to try and do this. Convert to, it's okay, but I prefer Tryparse a lot of times. Tryparse does a lot of it, unless you know the numbers that are going to convert are all floating point numbers and you're not going to ever have a problem, like you put in your own numbers, it's best to use some kind of a way of ensuring that you're getting good data, right? Especially when you're getting user input. User input, guys, like I said, is the #1 way of breaking your application. Okay, let's keep going. All right, so we did the Tryparse stuff, and it talks about that in a lot of detail. And here we have a bool, was successful is true, and then we can return from a particular method if the option is successful or not. Now notice what it says is bool static public static bool Tryparse. This Tryparse is a method that we've made, right? Kind of that we've created. This is what kind of Tryparse does. Tryparse does on the back end something that looks like this, right? So it tries to convert to whatever the conversion is, and then once it converts, this is a kind of custom method that converts to integer 32, by the way, not integer 16. If our number was really massive, right, then we'd have another issue. We'd have a different kind of error. Finally, okay, so finally is something that executes regardless. Okay, so sometimes at the end of a try catch, so something down here, we want to have another statement, a finally statement. And a finally statement, what it does is it executes all the time. So regardless, whether this test passes or fails, because this is the test. Here's what you're testing. You're trying to test to see, can I convert, right? Can I divide by this? Can I index my number, my numerator, right? As an example. If I can't do both things, then you know what? I'm going to get an error, But regardless, whether I get an error or not, this will always fire. So finally, always triggers. Always. Okay? It's not something that only sometimes happens. It always works. Now it says, notice it says redundant finally. It's an empty block. But if I put something in there, this always executes. Okay? Always. Whether I pass or fail. Okay, now you're going to say, you might ask me, like, why would I ever want this to happen? Well, think about it. If I want to check to see, I want to have some kind of output here as soon as this is done. I want to wait for the calculation to be over, and I want to make sure when the calculation is over, whether I get an error or success, I want to write something in there. I want to do an output to the console every single time I do an operation, right? Or I attempt an operation. I can put it in here. Okay, so I can run it, and I want to put a numerator that's 5 and a denominator that's 2. Then I'm good. You must enter a numerator between 0 and 4. We get that error, but guess what? I always get this always executes. Okay, so, and let's try it again. And let's say the numerator is 4 and denominator is 2. The result is 2. We're all good, right? The array value of the numerator as an index is 15, right? That's the 4th value. But guess what? This always executes, because regardless if we're good or not, it's going to execute. Okay, that's what the finally block does. So kind of straightforward. Okay, so that's what this does. And again, what we want to do is somehow the finally block happens in 3 ways, right? If the try ends normally, it fires, it triggers. If the catch executes, it triggers. And sometimes, and this is the last one, if the try ends abnormally and the catch does not execute. So that can happen sometimes. Like, for example, something happens where I get an error, right? But it's not an error that's going to trigger an exception. It's another kind of error, all right? And sometimes what we want to do is the finally block to kind of inspect our input or inspect our data, regardless of whether a try fails or not. Okay? And it gives you some examples here about how that would work. Okay? Sometimes also what we want to do is want to wrap a method inside of an exception. We can have nested tries as well, try catch, where we want to try something and then we want to try something else within a try catch loop, and it tells us how this works. So here, price list display item, we pass the item into the price list display, whatever the price list is, and it's going to return, it's going to do something, right? Notice here where I have the price list and then display price as an example. If I get the wrong price that goes in here, convert to 32 worked, let's say, but when I sent it to the price list, maybe something goes wrong in the method, because notice that the price list class has a display price that tries to output something. Okay, and notice it says price item, right? So this could go wrong. If, for example, here's inside my price list, I have 0, 1, 2, 3. I have 3 elements in my array, my double array, right? 3 elements, 0, 1, 2, 3. But something I pass into the element, I go beyond this, that could generate another kind of error, right? So it'll generate the index out of range error, right? But will it generate the error here, or will it generate the error inside my method? Remember, when I call the method, it gets popped onto the stack, right? This method, display price, gets popped onto the stack, or pushed onto the stack. And then when I'm done doing my method, it gets popped off the stack, and then, it's kind of out of bounds is what's happening. So will it do this try catch is the question, right? And notice it does in this example. So you can wrap a method inside of a try catch. You can also put a try catch inside of a method. That's another way to do it, okay? which is my prefer. And it talks about the call stack here, as you can get a trace. Now here, guys, I highly don't recommend doing if, else, or conditional statements without curly braces. It's been used here in these examples just to make this little code block a little bit tighter. But I don't recommend not having curly braces. So if I look at your code in the future and I see that there's no curly braces, that would be a bad thing. So please don't do that. Okay. But basically, this case study is basically trying to get you to understand how exceptions work. You can also make your own exception classes. Okay. So remember last time we were talking about classes, and this is really the reason why I wanted to talk about inheritance first. Because how can I talk about making your own exception class when we haven't talked about exceptions? We haven't talked about inheritance. So now take a look at what this is doing. I want to make a negative balance exception. So it's not really a exception that's going to be stopping the system, but it's going to generate an error that I don't want. For example, in this negative bank balance, you can't have a negative bank balance in real life. You can't go below zero, right? Now there's ways of catching this, by the way, if you have an unsigned int, right? As a value, but what if it's a floating point value or a decimal value, right? So, or there's some result that you're getting back that you don't want, okay? That would be very bad. So what you can do is you can take the exception class and extend it. So you can say that my class negative balance exception extends, remember the colon means extends, the exception superclass, right? And then what I can do is I can create I can pass in the message that I want. When I make an exception, I can pass in the message. The message is going to be bank balance is negative, right? I must pass this to the base. The base requires a message for me to send over to it. Once I've done this, guys, I have my own exception that I can catch, right? My own that I can define, and this is really helpful, right? So for example, maybe I want the user, they can't enter negative numbers at all. There must be positive numbers, right? But it's not unsigned ints or whatever. I just want them to enter positive numbers because I can't have a negative index, right? That would cause an index out of range or index out of bounds thing, right? So I can make a negative index exception class. Right, so let's try that. So if I go to my Solution Explorer, and I want to make a new item. I want to put this up on GitHub later for you guys. And the new item is going to be we're going to call this negative index exception. Of course, there is no negative index exception. We're making this up. And my negative index exception is going to extend the exception class. All right, so there's the exception class. Yeah, okay, I don't care about this. And what I want in here, when I extend this, the exception class, so I want to make my negative exception constructor, right? So here's my negative exception constructor, but I want to call the base constructor base, and I want to pass in the message. Notice it takes two things. It could take a string message, or it could take a string message and something called an inner exception. Okay, but let's just pass in a string message. We can pass it in right here. We can say something like the message. Notice it actually types in that by itself. This is resharper C#, right? So it says, hey, my message is going to be, you've entered a negative index. All right, so a negative index exception. It's like an index out of bounds, but it's negative, right? I'm making it up. All right, so this is the little class we're making, and I want to catch this negative index exception in my program, right? So I can say that, hey, you know what? When I get to index out of range, that's definitely something that'll trigger. But I also want to know if the index was negative, right? So I can kind of do that. I can say catch. And then I can put in the exception type. So negative index exception, right? That's my own little class I just made, right? And I can say that this happens, right, if my index is negative. Now notice in the PowerPoint what it did. So we have this exception, we have a string, we've set up our base, but we haven't really told it how to catch stuff. So when does this trigger? Well, it's always going to trigger because we really didn't define what a negative balance or a negative index exception is, right? So here what we're going to do is it says, okay, negative balance exception is equal to this new negative balance exception, and we're going to throw a negative balance exception. That's what this thing is. If my value is less than 0, right? If my value is less than 0, we're going to throw this thing. So what we want to do is exact. So notice this throw statement. That's an interesting thing. And I want to go out here and I want to say something like, well, I'm going to try and do this, right? But when it comes down to this, the numbers, the numerator is going to be 0. It's going to capture this. I'm going to say that, okay, if numerator, right, is less than 0 somehow, right, just like the same, we're going to say that negative index exception is going to be a new negative index exception. We need to do this better than I just did. So we did this part. Okay, this is the first part. So okay, so I'm going to say that, hey, my negative index, just like it says here, is equal to this new negative index exception if my value is less than thing, right? It says that it's inaccessible due to the protection level. Remember what we did? We messed up. We didn't make it public. That'll fix the problem, right? And what happened is I just used resharper because I forgot to make this public, right? That's all it did. Cool. Once we've done this, if this is true, we create our negative exception, and then we're going to throw an error, right? So this throw statement, like, goes back here. We throw this negative balance exception. So in this case, throw negative index, right? And what this negative index does is it creates the exception. This actually creates a problem. This is our test if numerator is less than 0. And so then we create our negative index exception, and our negative index is thrown. Once we do this, then down in the try catch, this negative index exception is going to work, and we can output that message. You must enter a numerator that is positive. Actually, this is actually a good message either way. We'll say a positive numerator. So another message. We can have messages on top of messages here, right? Or you can actually just output the negative exception index message. So let's just do that instead. Okay, there we go. Just to make it different. So we'll run it, and so far we're good. But we want to enter a numerator that is negative. So let's say -2, right? And then 5. And it's because you've entered a negative index. This always executes. Why? This always executes because it's this. Okay. Notice what happened though. So we did this. It threw an error here, and it never got to an index out of range. Notice that this didn't trigger. So why do you think this didn't trigger? -1 definitely was an index out of range, right? And we would try whatever we could normally to do this, right? Guess what? It never made it here. It never made it to this line, because as soon as we came to here and once I throw an exception, I use the keyword throw, I'm already in exception territory. So because I'm already generated an exception, it exits from this try block and goes into the catch sequence. Okay, that's how it would work. If I did this after, so if I did this after I did my numbers, after I did this part, right here, right? If I did this here instead of, after this, that would create a different result. So if I did this, and if I said, okay, -1 and then 5, you must enter a numerator between 0 and 4. Index was outside the bounds of the array. That was caught, but this was not. Why? Because this part generated an exception, which means it cast us outside of the try block inside one of the catch blocks. Okay? So if you want to make sure you catch this problem or show this problem, then you definitely want to have it before this happens. Okay? And it makes sense because you want to, this differentiates between these two types of errors. So you want it here. And order matters, right, in this case. Okay, let's keep going. All right, so that is your custom exception. That's what we just made. and it shows examples here of how to do that on your own. You can also rethrow an exception, right? But again, this is a little bit more rare when you want to throw an exception on your own. So notice what you can do is you catch an exception and you throw it again. You catch and throw the same exception. So notice that there's a private static. I'm going to put this a little bit bigger for you guys in the thing. So there's different methods. So here we have our static main, right? And we have some private static methods, method A, method B, and so on. And here we have a try catch, so trying method A, and we call method B, right? Method B goes here and says, okay, cool, try method A, call method C. Method C goes here, and then here it says we want to throw a new exception. So here we have a new inline exception. This came from method C, all right? So this gets thrown. This gets up to here, method C, right? We threw an exception. Any exception is caught here, which means it's going to say console writeline caught in method B. We're going to rethrow an exception. When we rethrow an exception here, it's going to be caught in method A's try catch. It's almost like method B is inside of method A, and method C is inside of method B. So we can have multiple layers of try catch, and that's why the extra throw statement is important here, because you have multiple ways of throwing exceptions. Again, a little bit more rare in terms of how often this kind of situation can happen, but knowing that you can rethrow an exception is a good way of catching all problems. Okay? And that's pretty much what I wanted to cover today. I wanted to end a little bit fast, and you can see that we went through this whole example pretty quick. That's all exception handling. Most of the exception handling that you need to know how to do, right? So normally we do that in a whole week. Myself, I don't think it's worthy to do in a week. I think you can do that much quicker. What is a system null reference exception, and when is it caused? It's a great question. And so think about when I want to make a reference, right? I want to make a reference to a new object, all right? So for example, I have an object. Let's do it here. It's easier for me to do it than to explain it. So let's suppose I have a new object, okay? And I want to make a new class. Let's make a new class for a second. And let's make a class called, we'll do a transform again, or some kind of vector class, okay? So very simple vector class, because it's an easier one to think about. So a vector class, and a vector class takes x and y as an example, right? Let's make it. So menu, add a new item, a new class. We'll make a new class. We'll call it the vector class, vector 2D. just like before, the class itself is going to have a float x and y, which we'll make public. Okay, yay, x and y. And by default, we want to have a constructor that takes in x, so float x, and we'll give it a default value of 0. And a y also is something we want in there. How about that, Tom? Float y, and that's also 0. And we want to have something like this, where we want to say that this dot x is equal to x and this dot y is equal to y. Yay! And to make it more interesting, we're going to make a public override. We're going to override the toString class. So I'll say toString, right? I'm going to override the toString so it prints out the toString nicely. So we're going to say that it's going to return a string. And we're going to say that it's going to return a string that looks like this. So this plus the number, which is going to be x, this dot x. Gosh, that was a bad typing. This dot x plus a comma, and then plus this dot y plus another bracket. Okay. So that is kind of a little string that we created. You could also have used interpolation here, but I just did it this way. Okay, yay, we have a little class. Fantastic. Okay, but now we create a, in our program here, we, instead of doing something, we say, I want a new vector, so I want a vector 2D. We're going to call this position. All right, there it is. And then down in here, in my try block, I want to output my position. So I want to say console writeline, the position vector is, and then plus position. Huh? And I want to do position dot toString, just so that way it works. And why isn't it giving me that error? Local variable position may not be initialized. Yes. So it actually saved us from doing it because it says that the position variable isn't initialized, right? But even if I did something like position.x nowadays, C# is good enough where it kind of detects this, right? And what's happened is it won't allow me to do this until, and this is smart of C# to do, until I do something like my position is equal to a new vector 2D, you know, as an example. That would work now because you can see now that it's, because C# is type safe, this would definitely work to some degree anyway. So this is good, right? But what if I have a list of positions, as an example, that I want to print out? So I want to add a bunch of the positions to the list, and I want to keep going, you know, as an example where, you know, let's say the list is empty. I want to add a bunch of new positions, and there isn't a reference. The reference points to something wrong. It's pointing to something that doesn't exist. That's when you can get a reference. It's more difficult to do, to generate a null reference error in C# with our little examples, because we have objects for everything. Objects are been created every single time, right? But there are some code, some programs that you, let's say, for example, this was allowed, where I didn't use this part at all. I didn't instantiate an object here, and I just tried to access position by itself. If C# allowed me to do this, right, then what it would do is it would generate this null reference exception because it doesn't exist, right? There is no object that I'm trying to access, or I'm trying to update something that also doesn't exist. I'm trying to call a method of something that doesn't exist, right? It would cause a null reference exception because there is no method of something that doesn't exist. Like example, I'm trying to update a game object, but the game object's never been created, right? So therefore, I don't have something that's not instantiated will cause a null reference error. Here I can't recreate it because C# is so good it stops me. Okay. Any other questions before we move on? Hopefully that explained it, Gurkidat. But it's basically this. So it's when I'm trying to access something that doesn't exist. It's the same thing as if I tried to do this, like, you know, the reason why it gives me this error is because guess what? I've never instantiated this thing before, so it automatically gives me an error, which is awesome. In other languages, example C++, it won't give me this error. It'll allow me to do this on my own, right? Or even in JavaScript, if you're running JavaScript and you're trying to pass an object, access an object's properties that doesn't exist, that would be bad too. A method usually is how that's done. You know, I pass in an object to a method, and the method that I'm passing into doesn't have an input, as an example, or it's the wrong type of input, and that would be bad. Okay, any other questions around exception handling? So exceptions are really there. Just wanted to talk about this. Exceptions are really there, or exception handling is there, so that way your program doesn't break. Okay, and usually you wrap some stuff like this, wrap your try catch around something that has the potential to break. Any user input is that potential. Okay, if you have, if a user can do something, move a mouse in a position, as an example, on the screen that causes an error, or input some numbers. And a lot of times, remember that no matter what user interface that we use, if I make a simple user interface with you guys, if a user can enter data, they can break your code 9 times out of 10 if you don't catch it, right? So that's why we use try catch more than anything else. Okay, let me put this up on GitHub for you guys so you can see it, and then we can go from there. So again, whenever we do GitHub, and now people have asked a couple times to do this, remember, we can do it in a couple ways. Team Explorer is I can go to Home, right? And right now, notice that if I went to Changes, there would be nothing. You're like, wait, no changes, how come? Well, because if you notice on the bottom right here, it says Add Solution to Source Control, right? So what I need to do is go to my Solution Explorer first, go to my solution, right-click, and go to Add to Source Control. Here. If I don't do this, Git repository has never been created for my app. All right, so Add Solution to Source Control. Right now, it's generated a new Git repository, right? Now this is great, but we got to put it up on GitHub. So the next part is, again, you want to go to Team Explorer, and then you want to go to Home. Notice that there's no changes because whatever my state of my code was at this point is where it's created its first commit. My first commit is already created. All I need to do now is push it. So I'm going to go to Home, Sync. There's no repository online, so that's why it gives me these two options. And I can do it in 2 ways. If I use my Publish to GitHub extension, then I can just click this button. If, however, I already have a repository, then I can use this button. So I don't have one, so I'm going to use this button. Okay, so it's going to say Publish to GitHub. I got to choose a repository and an account. My account is going to be Centennial. And my repository that I'm going to be creating is this one, COMP123 M2020 Lesson 7 Part 1. And then we're going to click Publish. I'm not going to click it as private. If I do this, then no one can access it. Only me or anyone I give access to. Publish. It's really built in. It's that simple. Now, some people have been having some really weird issues with Git and GitHub. They're telling me things like, I don't know why, Professor, but I can't push to GitHub. It really depends on how you create your GitHub repository. If you create your GitHub repository on GitHub first, for example, if I go to online, and if I go to my GitHub repository, here's GitHub, and let's go to Centennial, Here's my Centennial College, right? Notice that this is COMP123. This is our little repository, right? But my repository can also have a README file. So let's say if I go here, and let's say for whatever reason I create a README file up online, like this. And I say, okay, cool, I like it, and I make a README file, commit new file. Yay! Now this GitHub repo, as an example, wow, we're awesome, right? Everything's fantastic, but guess what? We have a big problem, right? Because now, well, not a big problem, but it's a problem. This repository, right, has 3 commits, but locally on my Visual Studio, I have only 2 commits. I only have 2 commits, right? Because I just pushed it. So if I go back to home, and if I go to changes, I don't have any changes. But if I make a change and I try and push it, they're going to be desynchronized. They're going to be desynchronized because I have an extra commit online. Look, I have an extra commit online. I have this thing that I made online that does not exist on my local repository. So I'm going to have an issue here, 100%. Because take a look at my commits. If I go to my commit history, I can see that I have add project files and add gitignore files, and that was done by Visual Studio. Create README was done by me online, right? So there's no way that it exists here. The only way to get to my README file here and to get myself back into sync, the only way, right, is for me to go to home, and then when I go to sync, I want to fetch, not pull. Pull actually pulls it down. Fetch checks to see if there's a commit. And you can see that I have an incoming commit, right? It will not allow me to push a new commit without pulling first, in this case. But it shows my commit. There's a commit that's online, that's been done by me, that has not been synchronized with my repository. I need to pull this commit now. And if I do this, now we're in sync again, and I can push back up to GitHub the next time. Okay? So again, fetch tells me if there's anything that's online that I don't have. Pull actually pulls it. Okay? Sometimes I don't want to pull every single time. Maybe what I want to do is I want to make something, stash it, and then pull it later. And we can talk about stashing later on. Okay, so that's pull and fetch. And if I go to home now, and I go to changes, again, no changes. And if I go to Solution Explorer, you're going to be like, wait, where's my README file? Well, remember, what you see here inside your C# is not reflecting exactly what's happening in the folder. Okay, so if I want to see what my folder looks like, right, I want to open my folder in File Explorer by right-clicking on the solution and going Open Folder in File Explorer. And if I was to do this, then you can see that there's the README file. That's the README that was pulled from online, right? Okay, but you don't see it here in Visual Studio. Okay. Why? Because Visual Studio shows you only the files you need to run in C#, and that's those files that are in here, in this folder. Okay. So hopefully that answers some of your questions when it came to Git and GitHub and how come you can't push. Sometimes people create funny repositories. When they create a new repository on GitHub, all right, up here, and again, I'll end after this. If I make a brand new repository, I have some options as well. I make a new repository. Let's make one called test. We'll call it test repo. Okay. Let's make it public. And then it asks you a couple questions down here. Do I want to initialize my repository with a README file? Yes, I do somehow. You check this. And do I want to add a gitignore file? Okay, let's add one for, I don't know, Unity or something, right? So I go, or Visual Studio. There's actually a bunch of different options here. Here's Visual Studio. So I want to add a gitignore file for Visual Studio. Cool. I want to add a license file. All right. I want an MIT license. Yay. Okay, and I do all this stuff, right? And then I press Create Repository. And when I do this test repo, I already have stuff suddenly in my repository. This stuff. And once I've done this, I'm already behind before I even push to this thing, right? So I have files. The only way I can continue is if I pull from here, right? But I can't pull because if I pull, then I'm going to wipe out what I already have, kind of, right? By the way, the MIT license this gets generated is quite neat. It talks about who owns it, right? And it generates a license automatically, and it's actually really cool if you're making your own software. Okay, let's go back to test repo. I want to delete my repo. This is something else you guys need to know. Sometimes you make a mistake, and before you hand in your assignment, your repo doesn't work properly, and you want to do it again. You can go to Settings, and there's a space way down here where it says Danger Zone. Okay, and down in the Danger Zone, you can click delete this repository right here. So if I click delete repository, you need to type in this or copy this. Normally what I do is I just copy and paste. So I'll copy this part, paste it in there. Has to be exactly like this, the name and the name of the account and the repo. And then it says, I understand the consequences, delete this repository because you can never get it back, ever. And then type in your password, like it gives you extra stuff to do just to prevent you from accidentally doing these kind of things, because it would be very, very bad, right? So you can see now that that repo is gone. Okay, any questions around repositories or anything else, guys? That's all I have for you today. Remember that on Wednesday when we get together, I'm going to give you your assignment number 3. And again, it'll be due in a couple weeks. I'm going to be covering I/O on Wednesday. So it's a kind of an important one, just like exception handling is. Remember that the test is also going to happen next week. So if you look at the kind of our schedule is that we're going to have a test next week, and I'm going to probably hold the test next week on Wednesday. I'll do a review of everything you need to know on Monday, and we'll test you on Wednesday. Okay, that's how the test is going to work. Typically what I do is I do a practical test where I get you to do something that's throughout the week. And what happens is, because we're remote the way we are, the test will be modified so that way you can do it in a couple of days. Typically that's how I do it if I do a practical test. Well, you have to also include a little video about how to do your what you're doing. Show me what you're doing, because it's got to be you that's doing the test. There may also be, I got to put this out there, some part of the test, like a part 1, that is true, false, multiple choice. You might have a true, false, multiple choice part, and another part that is practical that you hand in. Okay, so that's coming up next week, and the test is gonna cover everything that you've learned from Professor Narendra all the way down to me. That covers all this material. Okay. One thing that the test may not cover is test-driven development, because if I haven't covered something, obviously I'm not going to ask you to do something. Okay, with test-driven development. I'll probably cover test-driven development in the second part, which is all around user interfaces coming up. Okay, so that's what's happening next week. So again, for the test, you'll have access to your PowerPoints as well. My videos, everything that I've given you so far will be good to go, and you'll just have to do some tasks, and then you should be good to go. Any questions? Okay, guys, I'm going to stop recording. I'll stick around for any problems. Otherwise, I'll see you guys on Wednesday.